And the third chapter is on distributions. Now, in basic probability, we are having what do you mean by the probability? And we are having some axioms on probability. And we'll be learning about addition theorem. And we'll be learning about conditional probability. And we are having Bayes theorem. And the last one is on total theorem. And when it comes to the random variables, we are having only two. One is the discrete random variable, and another one is the continuous random variable. And in distributions, we are having binomial. We have Poisson. And we have uniform and exponential. And finally, about the normal distribution. Right. So if you ask me, the most important topics in where you have to focus more is on binomial, Poisson, and normal. And on both of these random variables, and from conditional to total theorem. So these are these are the major topics what you are having in probability and stats. Okay. Now, when it comes to the definition of probability, so like we'll be denoting the probability as P of E, and that is given by number of chances for an event to occur by the total number of outcomes. So this is the definition of the probability, and that will be denoting with M upon N, and that is equals to P. Now, the major thing what you have to remember in this one is the probability of non-occurrence of an event is given by 1 minus P of E. That implies the total probability for occurrence and non-occurrence of an event is always 1. That means what? P plus Q is equals to 1. And again, when it comes to the axioms on the probability, so there are three axioms. The first axiom will be saying that for A subset or equals to S, 0 less than or equals to P of A less than or equals to 1. And the second one, P of S is equals to 1. And the third one, if A and B are mutually exclusive events, then P of A union B is equals to P of A plus P of B. So mutually exclusive means what? A intersection B is equals to phi. Then we say those events are mutually exclusive events. Okay. Now again, these are the axioms on probability, and the main thing what you have to remember, some note points like P of phi is always equals to 0. That means the probability of an impossible event is always 0. And if I'm taking for any events, A and B, first one, P of A intersection B complement is given by P of A minus P of A intersection B. And P of A complement intersection B is given by P of B minus P of A intersection B. And P of A union B is given by P of A plus P of B minus P of A intersection B. So this we call it as addition theorem on probability. Now if you look at all these things in Venn diagram, now as we are saying A and B are any events, let us say this is the event A and say this is the event B. So this part, that means, let me shade the region. So the yellowish region is A intersection B complement. And again, this shaded region is A complement intersection B. And the middle one, as everyone knows, that is A intersection B. Okay. And whenever we talk about a few things, like whenever we talk about selection, we'll be looking at the combinations. Like out of n, if we are selecting r items, out of n, if r are selected, then they are selected in NCR number of ways. So there is n factorial by n minus r factorial into r factorial. Okay, so again, when it comes to the next type, that is the conditional probability. Now, what this conditional probability says is the probability of an event A given B has already occurred. Given B has already occurred, so that is called as the probability or conditional probability of A given B, and we'll be writing it as P of A by B, and that is P of A intersection B by P of B. And in the same way, P of B by A is given by P of A intersection B by P of A. Now, by the first one, P of A intersection B can be written as what? P of A into P of A by B. And from the second, P of A intersection B is P of B. I think I have written in a reverse way. This is P of B. And this is P of A into P of B by A. So these two together, we call it as the multiplication theorem on probability. And this is the probability or the conditional probability of A given B. And this is the conditional probability of B given A. Okay, now whatever the event which has already occurred, that always will be writing in the denominator. Now, again, when it comes to the independent events, now the events we say they are independent if the occurrence of one event. So if the occurrence of one event does not affect on the occurrence of another. On the occurrence of another. Then we say the events are independent. And remember, whenever the events are independent, there is only one mathematical way to tell whether the events are independent or not. That means if P of A intersection B is equals to P of A into P of B, then we say the events are independent. Now, if A and B are independent, say if A and B are independent, then the first one, P of A by B is P of A. And P of B by A is P of B. And if A and B are independent, then A and B complement, A complement and B, and A complement and B complement, all these are independent by default. Okay. Now, again, when we talk about the next concept, that is about the Bayes theorem. Now, what this Bayes theorem says is the conditional probability of an event EI given A has already occurred, that is given by P of EI into P of A by EI by the total theorem, that is summation P of EI into P of A by EI. Now, how do we identify that we are choosing this Bayes theorem or not? Or how do we identify that the question is on Bayes theorem? Right. And the total theorem, so the total theorem is P of A is the summation of P of EI into P of A by EI. Now, how do we identify that the question is a Bayes theorem or a total theorem? That is the main thing. Okay. Now, under what cases this Bayes and total theorem will occur? Now, always remember, if there are some mutually exclusive events like say M1, M2 and M3, or M4, let us say we are having some mutually exclusive events, and all these three events have one common event together. Like say when we talk about the manufacturing machines, let us say there are three machines M1, M2, M3, and say these three machines are producing some defective. Okay, so that means this defectiveness is common in all the three events. Okay, and if we are finding the probability of that defectiveness, so then I have to use the total theorem. And if the condition is given, that means if whatever the product that I have purchased is defective, I'm interested in knowing what is the probability that it is produced by some machine. Then we have to use this Bayes theorem. Okay. So if I'm having two or more than two mutually exclusive events, okay, and they are having one event in common, and if we are finding the probability of a common event, then I have to use the total theorem. And if we are putting some condition, then we have to use the Bayes theorem. Okay. Now, like say the question, I can say already we have discussed this problem in the class. Say there are two bags. There are two bags with one containing three red and four white, and another containing four red and five white marbles. Now, if a bag is drawn, or if a bag is selected and a marble is drawn, and a marble is drawn, then first one, if the marble is white, the probability it is from first bag. And if the question is like, then the probability the marble is white. Right. So if the question is given in this way, that means what? There are two bags, B1 and B2. So B1 is having three red and four white, and B2 is having four red and five white. Right? So now a bag is selected and a marble is drawn. Okay, so now as I'm having two exclusive bags, B1 and B2, and there is a white ball which is common, or white marble or red marble which is common in both the bags. So if I'm finding the probability that the marble is white, then which theorem I have to use here? Can anyone tell me? Which theorem I have to use here? We have to use total theorem, as we are finding the probability of a common event. And if the marble is white, so that means given the marble is white, what is the probability? It is from the bag 1. So here I have to use the Bayes theorem. So the best way, what I can suggest you people is, whenever you find a question in probability, okay, whenever you find a question in probability, always remember, first write down the question in a symbolic forms. That will help you in identifying which theorem when to use. Otherwise, it is very difficult for you to identify that which concept you have to use in probability. Why? Because as many times as you read the question, that many times you feel it is a new question. You are reading it for the first time. You'll be feeling in that way. So be careful whenever you are dealing with the questions on probability. Why? Because there is no straightforward, or there is no general method for solving the problems on probability. Right. Now, let us say, yeah, here is a question. A puzzle in logic was given to three students, A, B, and C, whose chances of solving P of A is how much? 1 upon 2. P of B is 1 3 upon 4. And P of C is 1 upon 4. So the probability that the problem being solved, that means what? The problem being solved means if all of them sit together, or what is the probability that the problem is solved? That means the problem that is solved either by A or by B or by C. Okay. So now, what is the formula generally for a three events? We know that P of A union B union C in set theory, it can be written as P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. This is the formula what we are having. But as per the given data, we have P of A, P of B, P of C, but we don't have A intersection B, B intersection C, and A intersection C, and A intersection B intersection C. So this formula is not applicable to this. Now, think whether A is it depending upon B or B is it depending upon C. No one is depending upon one another, right? So then can we say that these three students are solving independently? So as they are solving independently, now can I write according to De Morgan's law, A union B union C can be written as, or according to the probability, 1 minus P of A union B union C union whole complement. On the first slide, I have written it. So P of E complement can be written as 1 minus P of E, or P of E can be written as 1 minus P of E complement, right? So then I can use A union B union C as 1 minus P of A union B union C whole complement, or there is 1 minus P of A complement intersection B complement intersection C complement. Now, as A, B, and C are independent, their complement is also independent. Now, if you refer to the note points on the independent events, right? So if A and B are independent, then A complement and B complement are independent. That means what? P of A complement intersection B complement is P of A complement into P of B complement. I said that is the only mathematical way to tell whether the events are independent or not. So now I'll make use of it. So then this can be written as what? P of A complement into P of B complement into P of C complement. And there is 1 minus P of A complement is 1 minus P of A. P of B complement 1 minus P of B. And P of C complement 1 minus P of C. And that is equals to 1 minus P of A is half. P of B is 1 upon 4. P of C is 3 upon 4. Right? So then that is equals to 16 to 32 minus 3 upon 32. And that is equals to 29 upon 32. So A is your answer. Okay? Now, again, in the same way. So this is a question asked in the year 2016 for civil. If X and Y are two independent events, it is known that P of X is 0.4 and P of X union Y complement is 0.7. Which of the following is the value of P of X union Y? Now, if I know P of Y, then I can answer to this. Why? Because X and Y are independent. X intersection Y can be written as P of X into P of Y. But we don't have for this. So now P of X union Y complement can be written as what? P of X plus P of Y complement minus P of X intersection Y complement. So P of X, we are having it as 0.4 plus P of Y complement. As X and Y are independent, then X and Y complement are also independent. That is 0.7. Now, from both of this, I'll take P of Y complement common. Then that is 1 minus P of X is 0.4 is equals to 0.3. So P of Y complement, that is 0.3 upon 0.6, which is 0.5. And P of Y is again 0.5. Right? So I got P of Y value. Now we want the value of P of X union Y. And there is P of X plus P of Y minus P of X intersection Y. As they are independent, we can write it as X into Y. So P of X 0.7 plus 0.5 minus 0.7 into 0.5. And there is 1.2 minus 0.35. Right, so 1.2 minus 0.35, I think I made a mistake. P of X is 0.4, right? Yeah, 0.4. So 0.9 minus 0. Again here, this is 4. So then that is 0.2. And that is equals to 0.7. Option A is the right one. Now again, here is the one. So if X and Y are independent events, the probability that both X and Y occurs, X and Y occurs is 1 upon 8. And the probability that neither of this will occur, that means neither X is occurring nor Y is occurring, is 3 by 8. The probability of occurrence of X can be. Now, That is what I said. While reading the question, try to write it symbolically. If you are writing symbolically, then it is easy for you to identify what he has given and what you are supposed to find. Okay. So as x and y are independent, so then the first one can be written as p of x into p of y, and that is 1 upon 8. And p of x intersection, x complement intersection y complement is p of x complement into p of y complement. That is 3 by 8. Now let us say, so from here, let us say p of x is x and p of y is y, which is 1 upon 8. And the value of x can be written as 1 upon 8y. And p of x complement can be written as 1 minus p of x into 1 minus p of y is equals to 3 by 8. And this is 1 minus x into 1 minus y is 3 by 8. So that is 1 minus 1 upon 8y into 1 minus y is equals to 3 upon 8. Or this is 8y minus 1 into 1 minus y by 8y is equals to 3 by 8. So 8 and 8 will get cancelled, and if you simplify this, there is negative 8y square, 8y plus y plus 9y minus 1 minus 3y is equals to 0. Or this is y square or 8y square minus 6y plus 1 is equals to 0. So 4 2's 8. So 8y square minus 4y minus 2y plus 1 is equals to 0. So from both of this, we can take 4y minus 1 into 2y minus 1. So y is equals to 1 by 4 and y is equals to 1 by 2. Now if y is 1 by 4, then the value of x will be 1 by 8 into 1 by 4. So then that will be how much? That will be 1 by 2. And another option, 1 upon 8 into 1 by 2. So that is 1 by 4. So in the given options, I am having only B. So it can't be this one. So therefore, x is equals to 1 by 4 is your answer. Right. Now again, two players A and B alternately keep rolling a pair of dice. A fair die. Here he clearly mentioned a fair die. The person to get 6 first wins the game. Now, what is the probability of A getting 6? It is 1 by 6. And probability of B getting 6 is 1 by 6. Now, probability of A not getting 6 is 5 by 6. Probability of B not getting 6 is 5 by 6. So given that player A starts the game, the probability of A winning the game. So the probability of A's winning. Now, who is starting the game? As A is starting the game, Now you'll look at the chances when A can win the game. What are the chances of A winning the game? Okay. So as A is starting the game, in the first throw itself, A can win the game. Or if not, again, when he'll be getting a chance of winning, first A should lose and then B should lose. Then A will be getting a chance of winning the game. If he misses the third time also, again, when he'll be getting the chance? In the fifth time. Again, B misses, again, A loses, again, B loses. Then there is a chance of A winning the game. And the game goes on. And what is P of A? 1 upon 6. 5 upon 6 into 5 upon 6. So that is 5 upon 6 whole square into 1 upon 6. Okay, D is the answer. Plus 5 upon 6 to the power 4 into 1 upon 6 plus so on. So we can take 1 upon 6 common. So that is 1 plus 5 by 6 whole square plus 5 by 6 to the power 4 plus so on. So it is sum to infinity of geometric progression, that is A by 1 minus R. And that is 1 by 6 into 1 by 1 minus 25 by 36. And there is 1 by 6 times of 36 by 11. And there is 6 by 11. Right. Option D is the right one. Now again, let S be a sample space and two mutually exclusive events A and B are such that P of A union B is equals to S. What is the maximum value of P of A into P of B? Now, as P of A union B is S and they both are mutually exclusive, then P of A union B can be written as, according to the third axiom, P of A plus P of B. According to the second axiom, P of S is 1. Now let us say P of A is X and P of B is Y. So then 0.25, right, for in. Now let us say this X plus Y is equals to 1 and say Y is equals to 1 minus X. I want P of A into P of B. And there is X times of 1 minus X. Or there is X minus X squared. And let us say this is a function. Now what is f dash? 1 minus 2x. And if we equate it to 0, x is equals to 1 by 2. And f double dash is negative 2, which is lesser than 0. So f has maximum. And the maximum value is f of 1 by 2. And there is 1 by 2 minus 1 upon 4, which is 1 upon 4. And there is 0.25. Right. Now, here is the one. The chance of a student passing an exam, let us say P of passing an exam is 20%. The chance of a student passing an exam and getting above 90, P of P intersection 90%, above 90 is 5. Given a student has passed the exam, so given the student has passed the exam, the probability that the student gets above 90, So then that is equals to, how do we write it? So P of P intersection 90% according to the conditional probability by P of P. And that is 5 by 20 and that is equals to 1 by 4. Right. So B is the right one. Now again. Right. So here is another one. A
Good evening,
similar
sir.
model, but in a different way. An examination consists of two papers. Let us say P1 and P2. The probability of passing in paper 1 is 0.3 and probability of passing in paper 2 is 0.2. Given the student has failed the exam, now here the data is on passing. Option C, okay. So failing, right? So given the student has failed in paper 2, the probability of his passing in paper 1 is 0.6. What is the probability that the student has failed in both the papers? So P of P1 by P2 can be written as P of P1 intersection P2 by P of P2, and that is 0.6. Both the exams means P of P1 intersection P2, that is 0.6 into 0.2, which is 0.12. Right. Yeah. If P of A is 3 by 5, P of B complement is 6 by 7, and P of A intersection B is 1 by 4, then find P of A complement by B complement. Right. So P of A, he didn't mention that whether they are independent or not. So let us consider they are not independent. And what is the value of P of A complement? That is 2 by 5. And P of B complement is given as 6 by 7. Then P of A will be 1 by 7. And P of A intersection B is 1 by 4. Now I want P of A complement by B complement, and that can be written as P of A complement intersection B complement by P of B complement. Now, how do we write P of A complement intersection B complement? So we can write it as, okay, answer is B, right? So this can be written as P of A union B whole complement by P of B complement. And that is 1 minus P of A plus P of B minus P of A intersection B by P of B complement. And if you simplify that, so there is 1 minus P of A is 3 by 5. Sorry, this is B. So there is 3 by 5 plus 1 by 7 minus 1 upon 4 by P of B complement is 6 by 7. And this is 2140, right? So 140 minus 28 into 3. So 24, that is 84 plus 20 minus 35 upon 140 into 6 by 7, right? So here 7 will be going 20 times. So now what do we have? So that is 140 minus 104 minus 35. So that is 71 by 120. Am I right, Farin? Yeah. Okay. Now, so here is another one. So here we have been given P of A complement 0.4, P of B 0.7, and P of A intersection B is 0.2. Now, how do we write this P of A by A union B? So that is P of A intersection A union B by P of A union B. And that is equals to P of A intersection A, that is A union A intersection B by P of A union B. Now, A union A intersection B is what? Right, B is the answer. Oh, I'm sorry, guys. It is B complement. Sorry. Right. Okay, then. So your answer is B, that is 2 by 5. So this is all about your how do we identify the theorems and how do we write it symbolically. Okay. So this is about your basic probability and all. Now, when we look into the random variables, that is the next concept. So what is a random variable? A rule which assigns a real number for every event of a sample space. So that means assigning a real number for every event of a sample space. That we'll be calling it as a random variable. Now again, these random variables are classified into two. One is a discrete random variable and another one is a continuous random variable. Now, a discrete random variable means what? Which takes only integral values. Which takes only integral or integer values. And continuous means it takes all possible values in a given interval. In a given interval. So that we'll be calling it as a continuous random variable. Now, if we are defining the probability for this discrete random variable or the continuous random variable, that means what? The probability of a random variable, that we'll be calling it as the probability distribution function. Okay, so we'll be calling it as the probability distribution function. So the probability distribution function is again classified into two categories. Now, if we are defining it over a discrete random variable, then we'll be calling it as the probability mass function. And that probability will be denoting it as P of x is equals to xi. And if we are defining over a continuous random variable, then we'll be calling it as what? Probability density function. And we'll be denoting that probability density function as f of x. Okay. So now what we'll do from here is, from here we'll be applying the statistics for these random variables based upon the probability distributions. Okay. Now in statistics, what we'll be doing, let us say, let's talk about parameters and discrete random variable and say continuous random variable. Now the parameters, like the main condition is for a discrete sum of all the probabilities is equals to 1. And for continuous, now remember, for a discrete we'll always get summation. For continuous we'll always get integral. Integral from minus to plus infinity f of x dx is equals to 1. And the mean, that means the average, denoted by mu. For a discrete, it is given by mu is equals to summation x into p of x. Right, Farin? Let's see that. And for continuous, mu is equals to integral from minus to plus infinity x into f of x dx. And coming to the variance, that is denoted by sigma square. And for a discrete, sigma square is given by summation x square into p of x minus mu square. And for a discrete, for continuous, it is the same. Integral from minus to plus infinity x square into f of x dx minus mu square. And again, the standard deviation, that is denoted by sigma, and that is root over variance. And for continuous, it is the same. That is root over variance. And there is one more concept that we'll be calling it as the expectation. So the expectation, that is the average value. So the expected value is, it is the average value. Now, when we talk about the average value, so the expectation is denoted by E of x, and that is for a discrete, it is summation x into P of x. For a discrete random variable, and for a continuous, it is integral from minus to plus infinity x into f of x dx. This is for continuous. And similarly, the expected value of x square is given by summation x square into p of x for a discrete, and for continuous, integral from minus to plus infinity x square into f of x dx for a continuous. And if we are taking in general, that is the expected value of x to the power n is summation x to the power n into p of x for a discrete, and for a continuous, integral from minus to plus infinity x to the power n into f of x dx. And the expected value of a constant, so the expected value of a constant is constant only. Now, when we talk about the variance, so the variance of a random variable, that is given by E of x square minus E of x whole square, or that can also be written as E of x minus mu whole square, or in other words, that is E of x minus E of x whole square. And the variance of a constant is always zero. Why? Because a constant does not vary. And a variance of a random variable is always greater than or equal to zero. Once this was asked for civil variance of a random variable. Now, if I'm having a random variable, two random variables, x and y, then E of y, the expected value of y, is given by a into expected value of x plus b. And the variance of y is a square into variance of x. Right, so these are the things what we are having in random variables. Now, guys, shall we have a break of 5 minutes?
Yes, sir.
Right, so let's have a break of 5 minutes, and we'll start with the what we say, the problems on this. Okay.
Good evening, sir.
Yeah, good evening, Srikar.
Uh, I have missed a recent class.
Okay, right.
So can I know what happened, sir? And
I have explained linear algebra, Srikar.
okay.
Okay, right. You just ping me up. I'll be sending the notes to you. Okay,
Sir, pinging means what, sir? Here it
in
means
WhatsApp. In WhatsApp, you just send me a text. I'll read. I'll send the text, the class. Okay, the class notes.
okay, sir.
Right.
Um, and sir, I want to know one more thing, sir. In the exam, sir, how many questions will I get on probability? One or more than one?
You can expect 3 marks. If you are from which branch, Srikar?
Mechanical.
Mechanical. You can expect 2 to 3 marks, not three here. You can expect 4 marks if you are from mechanical means.
Okay, sir. But the thing with this probability is, sir, this is hard to understand.
Yeah, that's what I said. Like, coming to the topics, if you see, the basic probability, this part is very difficult to understand.
Hmm.
That purely depends upon your logical thinking. But whereas, why? Because there is no general formula. So you can't guess, like, how do we solve? So that's what I said. As there is no general term in your basic probability, so the best way to identify what question or what he is asking, the best way is write down symbolically. That is the only way I can suggest you to understand the questions on probability. But whereas if you ask me about the random variables and distributions, they are direct one. Like say here, all the formulae, whatever we have written on the random variables, they are all direct. There is no change in that. But whereas when you talk about this particular topic, with one word or with one letter, your complete probability or your complete formula will change. Like instead of or, if he's saying nor, then the probability will change. Only one letter is enough to change your complete probability. That is what I am saying. So, in order to overcome this, the best way is to write down symbolically. And whereas these two, directly you can understand and directly you can write down, as it is purely formula based about discrete and continuous. Okay. Right.
Okay, sir, here discrete and continuous is formula based.
Yeah. And even the binomial Poisson, even the distributions is also formula based. Like as we did it in calculus, it is totally formula based. Okay.
Yeah, okay, sir.
Right.
Second thing is, sir, it is maths, sir. What I have studied sub chapters, topics, sir. One is this linear algebra since December, then differential equations a bit earlier, and then nowadays I'm studying in this one only probability, but probability questions are hard to understand and hard to do, sir. They are
Mm,
difficult to
mm,
very difficult to understand.
mm,
And I also practice it calculus part, sir.
mm.
But sir, in that still also some questions are remaining to practice.
Okay. And
Uh,
for you, there will be one question, damn sure question from Laplace for mechanical and
Laplace.
yeah, for mechanical and civil. One damn sure question will be from Laplace, no doubt about it. Okay, and
Mm,
one more. You can't say which one, but numerical methods.
sir, numerical methods also, yesterday I saw they are also complicated. Maybe means, but sir, some questions are easy in it. But
Yeah.
and nowadays, sir, I'm not going for any new topics, sir. Whatever I have studied in that one, I'm doing questions of those topics
That's what
only.
Srikar, that's what I suggest to all the students. That is, before starting the preparation, okay, you look at the weightage of the marks. So, like say, if I study only numerical methods, Fourier series, Fourier transforms, and let us say Laplace transforms and linear algebra. I don't want to study any other topic. Let us say, assume, being a mechanical student or being a civil student, if I studied only this, hardly I can get only 2 to 3 marks. Okay.
Is it, sir?
Yeah.
5 to 6 marks will I get? Uh,
No. No. I'm saying no. No. That means when I talk about Laplace transform, When I talk about Fourier series and Fourier transform, when I talk about linear algebra, okay, and if I have studied some topic on numerical methods, okay, say out of 8 chapters, if I have studied only these four, I am 50% confident. That means I have studied 50% of the syllabus. Why? Because in mathematics, you are having only 8 topics. In that 8 topics, I have studied 4 topics. That means for sure I'll be getting 50%. That means I'll be getting 7 to 8 marks. We'll be thinking in that way. But Laplace, remember, if there is a question for mechanical in Laplace, he'll skip for civil. And if he is asking a question on Laplace for civil, he'll skip for mechanical. So civil and mechanical, it is in this way. If Laplace is asked for civil, then Fourier series and Fourier transforms will be asked for civil. Laplace for mechanical, Fourier will be for civil engineering. Okay, the questions will be asked in this way. Why? Because these two together is only one. He'll not consider two different chapters. Okay, so you can't say I'll be getting 4 to 5 marks. Okay,
Oh,
right. So
means
just you
means
look
sir,
at, yeah.
means now the exam took place, sir.
Mm,
So for the civil, they asked Laplace transform questions,
mm,
and when it comes to mechanical here only,
mm.
they will skip this Laplace and they will ask any other thing
There
like
will
that.
be two sets for mechanical. There will be two sets for mechanical, forenoon session and afternoon session. You don't know for which session he'll be skipping that.
Actually, sir, I downloaded my hall ticket of Gate, sir.
Mm.
It is of morning, sir. I have
Okay, that's what
this
I'm
time.
saying. For which session he'll skip, we don't know. Okay, you always look at the weightage. You start preparing as per the weightage. Like when you talk about the weightage of the marks and all, now,
Means, sir, engineering maths has a weightage of 15, sir. So I started
yeah.
preparing line by line. Means topics of linear algebra, topics of differential equation, vectors, calculus, and then in the other subjects, other topics in maths only. So I prepare in this way, sir. Means I see the weightage of maths is of 15, but in that of the topics like sir, I didn't saw means I didn't get them. But what I have done instead, sir, I see previous year question papers. The
Mm,
thing is, sir, I can see at least one or two questions from any topics. The question papers, sir. Let it be of linear algebra or calculus, etc. Sir. For example, sir, if you open previous year question paper or any other question paper of previous years, uh, what I see is, sir, sometimes I can see matrix questions one or two. Sometimes I can see more than two questions from any of these topics.
mm,
But still, also that's not an issue for me because anyway, I will study those topics.
mm. Right. Now, if you see or being for a mechanical and for a civil, I can suggest go till here. Damn sure there will be a 2 marks question on complex variables for mechanical, one or two. So 1 to 2 marks for differential equations, 1 to 2, for probability, 2 to 3, for linear, 2 to 3, and calculus and vector calculus together itself will be around 4 to 5. Okay. So you look at the weightage. As per the weightage, you start preparing. That's the reason why I'm covering these three topics in your revision. It is having 50% weightage of the marks.
Which three, sir? This linear algebra,
Calculus,
probability.
probability. It is covering 50% weightage of your marks. That is the reason why I have chosen these three topics. Okay. And that's what I'm saying. Preparing for 15 marks, that means preparing all these topics. Instead of this, you prepare only 10 marks and you be sure. That's it. You be perfect in that 10 marks and you just go and write it. Even that zero point 0.5 or 0.25 marks will take your rank to somewhere else. Why?
Means,
Because as the time is short now and you are preparing now, it is bit not difficult, it's highly impossible to cover all these things and keep all these things in your mind. Okay. So this is the strategy what I'll follow every time. I don't want who want 100%, yeah. If you are like say if you are preparing for engineering services exam, Shrikar, if you are
yes,
preparing
sir.
for engineering services exam, then I would suggest to read all. There's not engineering services exam, there's gate exam.
Okay, sir.
That matters a lot. Why? Because gate, even in 0.25 marks, will take you somewhere else.
Means a difference of 0.25 marks. Means this
Yeah,
0.25 marks will take me to high level.
the rank will be somewhere else. Arey yaar, I'll give you an example of mine itself. Only 1 mark, a difference of 1 mark. There is a huge gap between these two. Only
Is
one
it?
mark. Only 1 mark difference between 500 rank and 725 rank. You see, in that 1 mark, how many people got inserted? 225 people came. That is what the difference it makes in gate exam. Okay. So you go as per the weightage. You be perfect as per the weightage and you write down. Okay. Right. Srikar, shall we have a break here? A break of
Okay,
10
sir.
minutes. Okay.
Yeah, okay. Let us have a break, sir. But just I want to ask one small thing. Just now you're saying, sir, means in this gate exam. So the thing is, sir, I need to see weightage of specific topics here, and I have to
Yeah.
prepare as per them instead of
Yes.
preparing all.
Yes. Why? The time is
Okay.
short, right? Now, hardly you have 2 weeks. Yes?
Yes, sir.
Today is 19th. So, hardly 2 weeks. In the second week, you will be having the exam. So, it's a very difficult. So, as the time is short, be specific on the topics which is having more weightage.
Yes, sir. Okay.
Right.
Calculus and vector calculus, sir. I have studied, but the thing is, sir, in them only, sir, still some questions that need to be done and doubts are there also.
Yeah, you
Linear
can ping.
algebra. Okay,
Okay.
sir.
Right. Okay. Let's have a break of 5 minutes and then we'll discuss. Okay.
Yeah, okay, sir.
Right. Yeah, guys, are you there?
Yes, sir.
Right. So where we were at, we were discussing about the expectation and all. Okay. Now let's see only 2 to 3 questions, how the questions will be asked, like here. And this is the easiest one. So, right. So E of x plus 2 whole square. And that is given by, as it is a discrete, summation x plus 2 whole square into P of x. So x is taking which values? Sorry, 3x, not 2. Right, x is taking 4, 8, and 12. So for x is equals to 4, 3 into 4 plus 2 whole square into what is the probability for 4? 1 by 3. Plus 3 into 8 plus 2 whole square into what is the probability? 3 by 5. Plus 3 into 12 plus 2 whole square into what is the probability? 1 upon 50. And this is 12 plus 2, 14 square. So 14 square by 3, 24 plus 2, 26 square into 3 by 5 plus 38 square into or by 15. So you just simplify this, you'll be getting your values. And here, so machines produces 0, 1 or 2 defective pieces in a day with associated probabilities. So x is taking which values? 0, 1, and 2. Let x be the defective pieces produced by the machine and having the probabilities what? 1 upon 6, 2 upon 3, and 1 upon 6. The mean and the variance of these numbers respectively. So what is the probability? What is the mean? So mean is given by summation x into p of x, right? And 0, 2 by 3 plus 1 by 3, and that is equals to 1. Mean value is 1, so we are left with A and C options. Now what is the formula for variance? X square into P of x minus mu square. That is 1 into 2 by 3 plus 4 into 1 by 6. So 4 into 1 by 6, which is again 2 by 3 minus 1. And that is 1 by 3. So option A is the right one. Okay. So depending on the random variables, so this is how the questions you can expect. And again, it is a question of random variables asked for computer science. And again, there is a question asked for ECE. Like how do we solve E of 2x plus y is 0. So if we expand this, 2 into E of x plus E of y, and that is 0. And E of x plus 2y, that is 33. And how do we write this? That is E of x plus 2 into E of y is 33. Now if I am adding these two, so that is 3 times of E of x plus E of y is equals to 33. Then E of x plus E of y is 11. That's it. Okay, and again, there's a question asked for civil. So the value of H for this to be a valid probability density. Okay, so like density function means what? Integral from minus to plus infinity f of x dx should be equal to 1. But here the function is defined only from 0 to 3 f of x dx is equals to 1. Now, here the function is getting regularly changed at an interval 1. So that means 0 to 1 f of x plus 1 to 2 f of x plus 2 to 3 f of x. Now, in calculus, we have studied integral from a to b f of x dx. What it represents? It represents the area. So here, from 0 to 1, it is a triangle. What is the area of a triangle? Half, base is 1 unit, height is h. And from 1 to 2, so this is the area of a triangle. Half, base is 1 unit, height is 2h units. And the last one, from 0 to 3, 3h is equals to 1. So h plus 2h, 3h plus 3h, 6h is equals to 2, h is equals to 1 by 3. So it all depends upon how you look at the question and how you analyze that. Okay. And this is about the questions on these random variables. Okay. Now, if we look into the distributions, so depending upon these random variables, again, these distributions are classified into two, as we are having two types of distributions. If we talk about discrete, we are having and continuous. Now, if we talk about a discrete, you are having two. One is binomial and another one is Poisson. And for continuous, you are having uniform, which is defined in a finite interval. And another one, you are having exponential, and it is defined from 0 to infinity. And another one is normal, which is defined from minus infinity to plus infinity. So when it comes to the binomial distribution, so the binomial distribution is defined for a discrete, and the distribution function is given by ncx into p to the power x into q to the power n minus x, where x is taking the values 0, 1, 2, and so on till n, and it is 0 otherwise. And for a Poisson on the mean of a binomial distribution, that is mu is equals to n into p. And the variance of the binomial distribution is given by npq. And we'll be using the binomial distribution only when the experiment is repeated. So if the experiment is repeated, then we'll be using this binomial distribution. Always remember, there is no direct question will be given like using the binomial. It always says if the experiment is repeated, or whenever he's talking about number of items or number of objects or number of defectives. Okay. So there that is automatically understood that you have to use the binomial distribution. And again, when you talk about uh, Poisson distribution, right? So the Poisson distribution that is given by P of X is to mu, and that is given by, or lambda sometimes, e to the power minus mu into mu to the power x by x factorial, where x is taking the values 0, 1, 2, 3, so on till infinite, and it is 0 otherwise. And when do we use this Poisson distribution? So we'll be using this Poisson distribution when n is very large and p is very small, or or if only average value is given. Okay, if in the whole data, if he has given only the average value, there we'll be using this Poisson distribution. Okay, now for a Poisson distribution, mean is always equals to the variance. Mean is always equals to the variance, and that is mu, which is equals to n into p. Now, you will be getting this Poisson from binomial. So we'll be saying that this Poisson distribution is the limiting case of, is the limiting case of binomial distribution. That means as limit n tending to infinity, b of x is to n comma p is giving us the Poisson distribution. Okay, and to use the binomial distribution, we require two parameters, n and p. And to use Poisson distribution, you require only one parameter, that is mu. Okay, and again, when it comes to the uniform distribution, so as I said, it is defined in a finite interval, and its density function is given by 1 by b minus a, where x is lying between a and b. If x is lying between a and b, its density is 1 by b minus a, and it is 0 otherwise. And for a uniform distribution, mean is given by a plus b by 2, and variance is given by b minus a whole square by 12. And the standard deviation is b minus a by root 12. And again, when it comes to the exponential distribution, so when it comes to the exponential distribution, it is defined from 0 to infinity. And the density function of this exponential is given by f of x is equals to lambda into e to the power minus lambda x for x greater than or equals to 0, and lambda is strictly greater than 0 and 0 otherwise. And for a exponential, mean is given by 1 by lambda, and variance is given by 1 by lambda square. Okay. Now, sometimes what happens in exponential distribution is he may not give the value of lambda. Okay. he'll be saying the average value. Okay, like say, for example, if we talk about a question, the average lifetime of an electric bulb is 5 months. Okay, the probability the bulb lasts for at least 7 months. If this is a question, now you might be thinking, so in the whole data, only the average value is given. So I can say mu is equals to 5 months. So as only average value is given, we can find or we can use the Poisson distribution. Why? Because in the Poisson distribution, if only average value is given, I said we can use Poisson. Now, if you look into this question, only the average value is given. So you might be thinking we can use the Poisson. But the lifetime, is it a discrete or is it a continuous? Lifetime is a continuous random variable. It is not a discrete. Okay, so lifetime is a continuous random variable. So as it is a continuous, so you can't use the Poisson. Why? Because Poisson is defined for a discrete, not for continuous. Okay, so then here mu, as I'm having only the average value. So the mean for a exponential is 1 by lambda. That implies the value of lambda is 1 by 5. Then the density function, what it will become? F of x is equals to 1 by 5 into e to the power minus x by 5 for x greater than or equal to 0 and 0 otherwise. So you have to look into the case study on, or you have to look into the objects on which he is talking about. Okay. Right. Now coming to the last one, that is the normal distribution. Right. So the normal distribution is given by n of x is to mu comma sigma, and that is given by 1 by sigma root 2 pi into e to the power minus 1 by 2 into x minus mu by sigma whole square, where x is lying from minus infinity to plus infinity, and it is 0 otherwise. Okay. So if you people are having the notes on this, what we say, on this normal distribution, okay, just go with the notes which I have explained in the class. Why? Because there are almost 10 properties of this normal distribution. Okay. And all the questions or all the problems, you can solve it in by using these 10 properties. Okay. So just go with this, what we say, go with the notes which I have explained in the class. Or if you are having the access for the online classes or the recorded videos, in all the recorded videos, I have clearly explained about the normal distribution. Okay. You guys just have a look, and if you have any doubts, you can ping me at any time. Okay. Right. So this is about your, all about your probability distributions. Yeah, that's what, Srikar. If you have the access for the recorded videos, you can uh, look at those recorded videos. Okay.
Thing, sir, the thing is recorded videos means it will be there in the website, sir.
Yeah.
Not these ones, sir, which you are presently recording.
Yeah. Presently recorded also will be posted there.
But sir, I have checked, sir, nowadays, but I didn't get them, sir.
You can ask the time people, they'll be sharing it with you. All the recorded videos are there.
Okay, sir. Sir, recently I have asked, but they told such things won't be provided. We don't have such things facility like that. They told, sir.
Um, right then. So you just ping me, Srikar. You just message me in WhatsApp. Okay. I'll be sharing this complete notes of probability and stats.
Okay, sir.
Okay. So that you'll be having an idea about how the questions will be asked. And all these problems I have discussed there itself. Okay.
So, so compared to other topics, sir, this probability is more important. Sir, what I want to ask is, sir, which topic is best to prepare, sir, for maths, sir? Although I will come with many topics, but
Mm.
and nowadays also have prepared many things like linear algebra, differential
Srikar,
equations.
if you ask me, you be perfect in these two topics. Okay,
Okay,
without
sir.
getting confused. Why? Because as you said that it's a bit difficult for you to understand the questions on this basic probability. Okay. As we are running short of time, as we are having only 2 weeks for your exam, so what you do is you be perfect in these two topics. And I'm sure that definitely 1 to 2 marks you'll be scoring in these two topics.
Okay,
Okay,
sir.
right.
Mhm. Okay,
And
sir.
that's what, like, as I said about the topics, like, here, where it has gone, like, I've written all the chapters. I think it went in the beginning. Normal, right here. Yeah, so this is the weightage, Srikar. You just
Okay, sir.
have a look at this weightage and you start preparing yourself. Okay.
Mhm.
Now you don't prepare for hardly in this week. What you do is in this complete week, that means from 20th till 25th. If you want to study any new topic, you study new topic in these days only.
Yes,
And
sir.
from 25th, that means from 26th onwards, you do only revision. Don't go with any new topic from 26th onwards. Whatever the topics you have studied, whatever the chapters you have studied, whatever the subjects that you have studied, you just go on revising those chapters. Or
Yeah, okay, sir. Nowadays, sir, I have started doing revisions, sir, especially even when it comes to this maths, sir. The thing is,
Mhm,
sir, I'm doing revision of these chapters, sir. Linear algebra,
mhm,
differential equations, vector
mhm,
calculus, okay, along with calculus and probability and statistics also I'm trying, sir. But
mhm.
in pro but the questions in probability and statistics are quite are complicated to understand. They are difficult to understand, due to which I'm unable to prepare
Yeah,
unable to revise this probability except the formulas.
yeah. So
Remaining
that's
all,
what I'm saying.
yes,
In
sir.
probability and stats, you look at only random variables and distributions.
Random variables also have studied, but
Mm,
in that also I need to do more amount of questions because,
yeah.
okay, if I prepare these random variables, uh, I need the thing is I need to be able to answer maximum type of questions. If they give
Mm,
simple questions, I can manage somehow in the exam, but But thing is, sir, if they'll be complicated questions, and one more thing, sir, I often get confused also, sir, here. And during the exam also, sir, if I get any question of of the topic which I have studied, what actually happens is sometimes, sir, I unable to answer that question
Mm,
because I get confused or I will forget its formula and I will take one formula and write for it. But after that, I will come to know it's a wrong formula. So such
mm.
things will also happen, sir.
Yeah, that's what practice.
Yes, sir.
That
The
generally
top.
happens when there is a lack of practice.
The thing is, sir, which topic I will practice in extreme. Mostly, I can be able to perform such topics questions. Otherwise, simple topics I can perform or handle in the exam, sir.
Mhm. Yeah, you do good revision, Srikar. I can suggest only that. Revision matters a lot. For you, it takes a lot of time to be perfect in each and every topic. That's what I'm saying.
And sir, nowadays time is also little bit lesser. So due to it, sir, I'm facing problem to do revision, sir. Uh,
Yeah, you have to take out time, Srikar. That is the main thing. You have to take out the time.
so thing is, I'm confused how to revise also, but still also I'm trying, sir.
Okay. So, like now, what you do is in weekdays, you select for every 2 days, you select any two papers or two chapters. In that 2 days, you just focus only on the two topics or two chapters. And then on the third day, you write an exam or you write the exam on those two topics. Then you see how it will be.
Okay, sir.
Now, why? Because at this moment, you'll be confused a lot. Okay. Right. And is there anything from anyone else? Jagan, Saiteja, Joshi. Right. So that's it, guys. So that's it from my end. If there is anything, so today I'll be sharing the notes of today's topic. Okay.